Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about geometric data tools, various tools that haven't already been covered in previous lessons. So what I have on the screen here is my HEC RAS, my geometric data editor with a very simple river system sketched in. And the tools that we talked about in previous lessons are the first ones here. If you go to the tools menu, we've already talked about cross-section interpolation, channel modification and design, and so on. Check the playlist for previous lessons if you're curious, though. In this video, I'm going to be talking about the tools down here at the bottom of the list, starting with ineffective areas and all the tools listed down below that as well. So I'm not going to list them all out. We'll talk about them one at a time, starting now. All right, so first is ineffective areas. So let me first go ahead and look at the cross-section data and then go to River Station 0. So this is the cross-section at the bottom of the reach. There are two ineffective flow areas. Right here, you can see they're sketched out in green. And I can go options, ineffective flow areas. And instead of just normal, I have the multiple blocks. So there's one ineffective flow area here on the left overbank and another one over here on the right overbank. As you notice, they're currently not set to permanent, hence the N character here. So we could actually make the change right here. But for instance, if you had a number of different reaches and a number of different ineffective flow areas, it may be easier to make this change not individually here in the cross-section data editor, but rather in the geometric data tools, ineffective areas set to permanent mode. What you're going to do next is select the river, select a reach, and then for node type, I just have cross sections on right here. So you could use other nodes as well. And I toggle that off. And then select your river station. So you can select all your river stations by double clicking or just selecting and then clicking the arrow button. I'm just going to select this one cross section here for River A Reach 1 at River Station 0. Okay, so then all I have to do is click yes, and that switched the ineffective flow area to permanent for all the ineffective flow areas on that cross section. Let's go ahead and double check. So I'll click cross section, River Station 0. Now if I click on options, ineffective flow areas, it changed that permanent from N to a Y, from basically no to a yes. Okay, so that's how that happened. I'm going to go ahead and just leave it like that. If I go back to the geometric data editor, tools, ineffective areas is fix overlapping. Here, what this tool does is search through all the cross sections and check and fix any ineffective areas that overlap each other. The stationing of the block with the lower elevation will be adjusted to prevent overlapping. So I'm actually going to click no here to kind of show you what I have set up so we can do it before and after. I'm going to click no, click on cross section. Now go up to cross section 1000. I have this prepared over here. You see in the diagram that I have two ineffective flow areas in the left overbank, and they do overlap. So this first ineffective flow area here, let me break out the, here we go. The first ineffective flow area here on the left has a cross-section station from 125 to 225. And then the second ineffective flow area here has a cross-section station starting at 175 going to 275. And that has an elevation of 80. So 75 and 80. And you notice there is an overlap. So what's going to happen when I use this fix overlap tool is it will switch this station from 175 and 225, and it'll switch it down to 175. Okay, so let's go ahead and check that out. Let's go tools, ineffective area, fix overlap. This time I'm going to say yes. It said it one cross section modified to fix overlapping ineffective areas. Okay, let's go ahead and check that out. I'm pretty sure it's right here. And there we go. As mentioned, we see the diagram has updated. The station has changed. Let's go ahead and look at the numbers. And sure enough, this value here used to say 225. Now it says 175. Making this change is helpful for the model and is going to help prevent compute errors once you go ahead and run a simulation. Okay, there's one final ineffective flow area tool here in the geometric data editor, and that is called convert multiple blocks to single normal ineffective flow area. This tool will convert cross-section of multiple block ineffective areas to a normal single ineffective flow area for that overbank. So there will just be one normal ineffective flow area for the left overbank and right overbank, but not multiple. So I went ahead and set up a cross section at River Station 2000. Go to options, ineffective flow areas, and then we have the normal radio button and multiple blocks radio button. So I'm going to go ahead and select multiple blocks, but what this tool is going to do is convert it back to normal. Let's go ahead and set up a similar ineffective flow area that we saw with the previous tool, except this time at a different river station and on the right overbank. So multiple blocks, river station. Let me look at my numbers over here. This is going to start at 725 to 825. So we'll just type that in, 725, 825. We'll say that's elevation of 75. And then we can also do the overlap here. We'll say 775 to 875, and that will be an elevation of 80. All right, so I got those sketched in. I'm going to click OK. And now we see the ineffective flow areas have now populated and display in the diagram. I'll click Apply Data. And then let's go ahead and run that tool to convert multiple blocks. Okay, so tools, ineffective areas, convert. That was cross section 2000 and OK. One node with multiple block ineffective areas found and converted to a single ineffective area. All right, let's go ahead and see what happened there. Go to options, ineffective flow areas. And now we don't have any data in the multiple blocks. It's all been converted here to one single point here on the right overbank, which has a station of 725 and an elevation of 75. Okay, let's move on to the next tool here. I'm in the geometric data editor, tools, and now we're moving down to Manning's N, set channel to a single value. So if I click that, it brings up this dialog box. What I need to do here is prepare the data. So what I'm going to do is come back to this. I'm going to go to the cross section. We're going to use cross section at River Station 2000 once again. Now, never mind the ineffective flow area. What I want to do here is look at the Manning's N for the main channel at 0.03. But what I'm going to do is I'm going to set it so that this center section between these two stations is 0.02. And then what the tool is going to do is set a single value, which will be at the low point of the channel. So the tool is going to set it to 0.02 for the entire channel. All right, so to get started with that, we'll go options, horizontal variation and end values. I'm going to set this to 0.02 and then 0.03. Okay, apply the data. Now up at the top, you see that we have 0.03, 0.02, and 0.03 based on the stationing. All right, when we run the tool and come back here, it should say 0.02 for the entire channel. Let's go ahead and test that out. So we'll go to Geometric Data Editor, Tools, Manning's N. Okay, and that was the cross section at River Station 2000. So, okay, let's go ahead and see if that worked. And sure enough, it did. Now we have 0.02 for this entire main channel. Okay, so I'm going to close that. The next tool in the Geometric Data Editor is Vertical Datum Adjustment. And if you scroll over, we got a number of different options here. Entire geometry, table, and then selected elements. I'll start with entire geometry. So if you wanted to raise or lower the entire vertical datum for the elements in your model, in your geometry file, that's how you would do that. Let's go ahead and take a look at River Station 0. The cross section here has a vertical datum of 30. That's the invert of the main channel. So just keep that in mind, 30 feet. All right, let's go back and make an adjustment now. So tools, vertical datum, entire geometry. I'm going to add or multiply. We'll do an add and we'll just say 10 feet. And then there's a few other options here you can select, but I'm just going to click OK. Now we should see an increase of 10 feet everywhere in our geometry data. And sure enough, we do. So that invert of the main channel at River Station 0 is now 40 feet. Okay. So I'm going to go ahead and set that back to what it was at 30 feet. Tools, vertical datum adjustment, entire geometry, and then we will say minus 10 feet to set it back. We can also use a table to make the same changes. So we'll go to Tools, and then Vertical Datum Adjustment, Table, and I have the different cross sections here, 0, 1000, and 2000. Let's go ahead and only use 1000, and I'm just going to say 5 feet this time. So I typed in a 5. What I'm doing is adding. There's also add, multiply, the same rounding precision tools as we saw before, as well as some buttons here. So for instance, if I wanted to select a number of different cross sections and make edits using these buttons, that those features are available as well. But anyway, let's keep it simple for now. I'm just going to add 5 feet, so that invert should now be 35 feet. So I'll click adjust and close. Now let's go ahead and double check on that cross section, and there we are, 35 feet for our invert at river station 0. All right, and just to be complete, I'm going to change that back using table, and then I'm going to type in a -5 and then adjust. We can also make adjustments to storage areas, such as this storage area here, as well as other features, some of which I don't have sketched in. But let's go ahead and take a look at this storage area. Here we have a base elevation of 620 with a volume of 0. And then as the elevation increases, so does the volume. What I want to focus on here in this isolated example here is the invert elevation. So let's increase the elevation of just this storage area by 10 feet. So after that, we'll return and should see 630, 639, 644, and so on. Okay. So let's go Tools, Vertical Datum Adjustment, and then we're going to say Selected Storage Areas here. There's also pump stations and storage area connections, but let's just go Storage Area, and then we'll select our Storage Area 1, and then OK. Now it's basically the same sort of interface we saw before, where we can add or multiply. We're just going to add 10 feet, click OK. All right, let's go ahead and see if that changed it or not. We can edit storage area that way, or we can come over here to storage area and then select the one we want to edit. Here we have our increased elevations. Now we're at 630, 639, 644, and so on. I'm just going to go ahead and leave those as they are. Okay, a few more tools to go. We have reach connectivity. So I don't have a whole lot of reaches sketched out in my system right now, but I'll read from the user's manual what this tool does. This tool allows the user to view how reaches are connected together. When working with a very large model with lots of reaches, it can often be difficult to see how the reaches are connected or if there's a problem with that connection. So you can see how the table would be populated with a number of different reaches, the river, the reach, the upstream junction, downstream junction, as well as any potential upstream or downstream storage areas. So I'm going to close that. And then the next tool here is reach order for computations. Also, I don't have more than one reach in my model right now, but I'll tell you what the user's manual says about this tool. When this option is selected, we see a table showing the order of the reaches for computations listed from upstream to downstream. This is the default ordering, but the user can change this order. So we'd have a number of different rows, one row for each reach. And if you select the reach, you can move it up or down. In this case, it's grayed out because I can't move one reach up or down. There's only one reach. But there's also a warning to say that changing this order could cause the model to fail during compute. So if you don't have a good reason to change the order, I'd probably just leave this ordering the same. Leave it as the default value. Okay, so I'm going to close that. The next tool is the reach order, find loops that prevent backwater solutions. So I'll click that. It ran automatically. It said no loops were found in the system. That's not surprising. This tool will search through the model schematic and find any loops in the system that will cause backwater computations to fail. This can occur if the user puts in a looped system and would continue to loop the water. All right, we have two final tools here in the geometric data editor. We go tools, there are flow roughness factors and seasonal roughness factors. So let's click on flow roughness factors first. This option allows the user to adjust roughness coefficients with changes in flow rate. This feature is very useful for calibrating an unsteady flow model for flows that range from low to high. Roughnesses generally decrease with increase in flow and depth. So what we want to do is click on this river station, select the river station. So we'll say upstream is 2000, downstream is 0 for my entire reach here, and then click OK. And now what I'm going to be doing is typing in flow values over in the left column and then roughness factors in the right column. All right, I've gone ahead and added some example data here for flow and roughness factor. As you notice, the flow increases and the roughness factor decreases. Right here is the user's manual, and here is a perhaps better example with more numbers. So I'm going to cancel that. I'm not going to save it. And then the last tool here is seasonal roughness factors. This option allows the user to change roughness with time of year. This feature will most commonly be used on larger river systems in which temperature changes can cause changes in bed forms, which in turn causes changes in the roughness factor. So what you do is, again, select the river, and then select the reach, and then select the range of cross sections between which this change in roughness factor applies, and then go ahead and just start typing in the roughness factors for each month. So you can use the month, but I believe, yes, you can also change it to just the date of the change itself. So you don't have to use once a month. All right. So I'm just going to cancel that out and let you know that that's how that works. All right, well, that was it for this lesson. We talked about a number of tools in the geometric data editor. So you click on geometric data editor and then tools, and then all the tools from ineffective areas down through seasonal roughness factors we talked about briefly in this lesson in HEC-RAS.